So last day we talked about vectors. I wrote here, recall, I was only a scalar until you came into my life and gave me direction. You are the vector of my heart. Wouldn't that be a great love song? That would totally work in my mind. Without you, I was just a scalar, but now that you're... Okay, whatever. Person walks 6 kilometers... Oh, I see the word north. I'm drawing a compass rose. A person walks 6 kilometers north and 4 kilometers east. What's their distance traveled? You'll notice I only gave you one line. That probably means that I'm expecting you to be able to do this in one line, maybe even, dare I say it, in your head. What's the distance that they traveled? 10 kilometers. Direction. It's a trick question. Distance is a scalar. What's their displacement? Well, now I'm going to add these two vectors together. Kira, if I want to add these together, how should I draw them? Tip to tail. It doesn't matter whether you draw the 6 first and then the 4, or the 4 first and then the 6. We will get the same answer. You'll get the different angle. You'll get the complementary angle. I typically will go with drawing things in the same order that they gave them to me in the question, just because I think that's what most of you will do, and that way, in theory, our triangles look the same. So I'm going to go 6 north plus 4 east, a little bit shorter than the 6. And if I draw that tip to tail, now again, I think I said this last day, but I'll repeat myself. If you want to get these wrong, do dumb small triangles. I will typically give you lots of room to do a nice big vector triangle. It helps dramatically. Don't do little microscopic ones. So I'm going to go 6. 4 is a bit shorter. And the resultant displacement will be that there. Where will the theta go? Top or bottom? Before you go to your calculator, that 4, opposite, adjacent, or hypotenuse? That 6. Here's your challenge. Can you get the magnitude and the direction without writing anything else down, going straight to your calculator? If you can, that's honestly how I would do this in my homework. On a test, I would show more work. I would probably write out at least one line of Pythagoras. I'd probably write out the trig function. But if you're asking me if I'm in a rush, oop, round off properly, Mr. Dueck. Am I right, I think? I do not advise doing it with that little work on a quiz or a test ever, Ange. And maybe I'm not even sure I advise doing that on question number 1 of the homework. But on question number 30 of the homework, when I'm in a groove, if I'm cutting corners, I could probably do that just on calculator, not writing anything down. I got 7.21 kilometers at, I think it was 33.7 if I round off properly, 34 degrees east of north. Or if you drew the 4 first and then you drew the 6, you would get 56 degrees north of east. But you still get the 7.21. Is that okay? Yes? Alrighty. How do we add two vectors together? Draw them tip to tail. How do we subtract vectors? Oh, yeah.
I was just wondering for the first question, you might have said already, but why is it that the arrow moves on the hypotenuse? Why is it going backwards?
Always from the tail of the first to the tip of the second. Yeah, if you think about it, we're going up and to the right, so our arrow should be pointing up and to the right. And then theta always goes where the vector arrow is originating from, not to where it's pointing to. Okay, that's the convention we've agreed on for the way we do directions. How do we subtract vectors? The short answer is we don't. What then? I always pause because 15 years ago, I did have young Jordan Sakila, the same young man who wrote the test in radians, but was still one of my strongest students ever. All of a sudden, as soon as I said we don't, he went, oh, and he gave me what we do instead. So I'm going to pause. We don't subtract vectors. What do we do instead? Reciprocal? Nope. But you're on the right track. Yeah.
So if you have a vector pointing like 8 meters east, then you just go and you add 8 meters west.
We're going to add the opposite. Yes. There, by the way, there is a rule for subtraction. And when I was in university, my prof actually made us learn the rule. How do you subtract two vectors? You draw them tail to tail, and then the resultant goes from the tip of the longest vector to the shortest vector. But why would I make you memorize an entirely different rule when we can turn any subtraction into addition? How do we add two vectors? Draw them, Liam. How do we subtract vectors? We're going to add the opposite. We're going to use the idea from arithmetic that 5, don't write this down, take away 4, answer in your head, is exactly the same as 5 plus negative 4. Answer in your head, still 1. So in vector symbols, if you give me vector A minus vector B, I leave vector A as is, but I add the opposite of vector B. And what would the opposite of vector B be? If vector B was originally west, its opposite would be east. If it was originally pointing south, its opposite would be north. I prefer that because if those of you that had me before know, if I can just use something I already know and adapt it to the new situation rather than memorizing a whole new thing, oh, I'm in. I could have taught you different force equations for every possible situation. I said, no, I'll go winner minus loser equals MA and free body diagrams. I can use that for everything. So, supposing F1 is 6.8. Oh, I've turned the page, so I'm doing a compass rose. You might already have one on your page somewhere. If F1 is 6.8, that N, is it north? How do I know? And this is where I said, Paige, we've run out of letters in the alphabet. If it was after an at symbol, that's a direction, north. But since it's right next to the number, newtons, right? Due west, and F2, 12 newtons due north. What's F2 minus F1? I typically write this, F2 plus negative F1, Fi, F1. I change the subtraction to addition. I do write that line down until I get really good. Kathy, what direction is F2? Magnitude and direction, actually. How big is F2? Magnitude? Direction? Let's draw that underneath F2. Plus. Kathy, what's F1? Magnitude and direction. Before I muck around with it, just read it to me from the question. How big is F1? Direction? Just west. So what would negative west be? East. So I'm going to point 6.8, which is about half as long as the 12, to the east. Negative west. Kathy, is there a plus sign right there now? Have I turned the subtraction sign into a clever addition question? Well, how do I add two vectors together then? Draw them tip to tail. So it's going to go yoink, 12, yoink, 6.8. Kira, from the tail of the first vector to the tip of the second vector. In this case, it's going to be going up and right. This is F2 minus F1. If I do the Pythagoras, what's the magnitude? Let's see, 12 squared plus 6.8 squared, because it's a hypotenuse, it's not going to be 12 squared minus 6.8 squared plus square root. 13.792, 13.8. If I go to 3 sig figs. Newtons, units, at, where's theta going to go? Bottom left or top right? Where's theta going to go? Bottom left or top right? Julianne? Bottom left, where it's coming from. And again, yeah, I turned it into an addition question rather than memorizing a new rule, and when I just turn it into math that I already know. So theta is going to go right there. That's 6.8, opposite adjacent to hypotenuse. Opposite. That 12, adjacent. Again, I could use the 13.8, and I could do it with cosine or sine, but if I got that wrong, then I'm going to get theta wrong. Why not use the numbers that they gave me? And it's easier because it's already labeled on my triangle quite conveniently. So it's going to be tan again. I get tan theta equals 6.8 over 12. And I get 29.5, 30 degrees. North of south, east of west, what of what? It's either east of north or north of east. Which one? As east of north, because my lines finish last. Mr. Dueck, when would you subtract vectors? You gave us a nice example where we added the vectors for that airplane question. It was kind of a cool application. When would you subtract vectors? I'm so glad you asked. Supposing the final momentum is 36 kilogram meters per second north, the initial momentum is 17 kilogram meters per second east, then what is that delta actually an abbreviation for? And boys and girls, what's change in anything? Did you say minus? Oh, anytime I'm doing a change in, I will be doing a vector subtraction. I like this question. I like this question. I like this question. This is a nice question. So they want me to find delta P, which is going to be final minus initial. My new students, I made my students memorize this last year. Change in anything is final minus initial. Change in anything is always going to be final minus initial. So Ben, what's the final magnitude and direction, please? Magnitude and direction.
That's going to be 36.
Direction?
North.
You know what? I've scrolled down, so I'm going to put a compass rose. You don't have to if it's on your page somewhere, but I will. 36 north, so final is going to be right there. Oh, wait a minute. Ben, how do I subtract vectors? I don't. What do I do instead? I don't want to rewrite this equation, so look up, everyone. I'm going to go plus negative. There, I just changed that to my vector subtraction. So what's the initial? 17, what's the initial direction? What's the initial direction? What's negative initial direction? So I'll point my 17 to the left. By far, the most common mistake here is I'll ask kids to find the change in, and they'll just add the vectors. They'll get the right magnitude, wrong direction. How will I add these together? Draw them. Now, I have to imagine this. Do you notice, Ben? Look up. I'm going to go up. First of all, this scale is terrible. This should be about half as long as that. So I'm going to just fix it. You don't have to, but it should be about like that. I'm going to go up, and then I'm going to go to the left. If I'm going to draw that, my up needs to move over. I'm going to do the 36 over here somewhere, and then go 17. Kira, which way is the resultant going to point? Up and left or down and right? Always from the tail of the first vector to the tip of the second vector. Sadly, it's going to be up and left. That's okay. This is new. This is the Physics 12 stuff. And I'm going to label it delta P, because that's what we call it, change it. Let's do the Pythagoras. The magnitude. Sometimes if I give this question to you on a test or a quiz, just to save you time, instead of asking for both magnitude and direction, I might only ask for magnitude, so you do Pythagoras and quit, or I might only ask for the direction. You can do the shift, whatever trig function, and quit without doing the Pythagoras. That's just because I've looked at the quiz or the test and I've thought, it's a little bit too long. Here's a way I can save you 30 seconds. You get 39.8 magnitude?
Yeah.
And the units for momentum were kilogram meters per second. I think I told you last year they're talking about renaming that unit an Einstein, but it just hasn't happened yet. So, direction. Where is the theta going to go? Top left or bottom right? Opposite. Adjacent. Is it always tangent? No, I'll show you some later today where it won't be. But for the easier ones that I'm starting you off with, yes. Shift tan of opposite over adjacent. Wow, that didn't work. You get 25 degrees? North of south, east of west, what of what? That's west of north, I agree. Or 90 minus 25, 65 degrees north of west. Usually for the subtraction ones, we'll almost always do it in the same order, but... How do I add two vectors together? Draw them tip to tail. What if I give you the resultant? Can you give me the original two vectors that make it up? We call this breaking a vector into its components. We can break any slanty vector into its vertical. Usually we use the letter Y as an abbreviation for vertical, and its horizontal. Usually we use the letter X as an abbreviation. Components. Example 1 says, find the vertical and horizontal components of this vector. So it looks like we're going up at 38 degrees, and the vector itself is 42 meters per second. I don't know whether up is north. They haven't told me that. Up could actually be up. This could be a side view. I don't know. But for now, they want us to find the components. Here's what I would like you to do. Do a little dotted line right to about there. Paige, what are the units on this vector? What per what? Which means it's a speed or a velocity. So I'm going to call this V and then X for horizontal. If it was a force, I'd call it F, X for horizontal. If it was momentum, I'd call it P, X for horizontal. And then I'm going to go dotted line like that, pointing straight up. And that is the vertical component. I'm not doing Pythagoras here. But I am going to label the triangle. What's that 42? Opposite, adjacent, or hypotenuse? I should have gone like this. Color. What's Vx? Opposite or adjacent? Adjacent. What's Vy? Cool. The only side that I know is this one, so I'm going to have to using trig functions that have an h in them. Liam, what do you want to find first, Vx or Vy? Doesn't matter. Pick. Vx. That's going to be right there. Which trig function? Cos. So cos, what always goes next to the trig function? The angle, and this time I know it, 38 equals adjacent over hypotenuse. Liam, how would I get the Vx by itself? So you're saying Vx is going to be 42 cos 38? $33.1? Now let's find Vy. Which trig function? Sine? Told you it wasn't always tan. What always goes next to the trig function? The angle. Vy over 42. Hey, how would I get the Vy by itself? Same as I did the Vx. Look up, everybody. Little time saver for you. So I just did that, and I noticed that Vy is exactly the same, except instead of a cos, what do I have sitting there? Most of you have a calculator that will let you backspace and edit, and you can just make that a sine, and it's less typing. Have I gone on a rant about getting a good calculator? I hope I have. 25.9. Meters per second. Yep. Then I would be using a found answer to find another found answer, which means if I got that wrong, I'm getting that wrong. And it would be more typing than just going backspace and changing the one thing. So yes, but I never would. Quick look, bunny. I could check my answer, though. If I go 33.1 squared plus 25.9 squared, square root, that should be 42. It's not quite because I rounded this off and I rounded that off, and so I've introduced error, but it's close enough. I'm pretty sure I've got everything right. I might do that later if I was checking my answers before I handed in my test. So, going up at an angle 38 degrees above the ground at a velocity of 42 meters per second, that's the same as traveling 33.1 meters sideways whilst simultaneously traveling 25.9 meters up. They're mathematically identical. And we're often, almost always, going to take a slanty line and refuse to deal with it. We will break it into its components, its horizontal and vertical components, so that we can wrap our brains around it easier. Find the components of this force here. Well, I would go to where the vector is starting from, and I would go and I would call that fx. Sound effects are optional, but they help. And I would call that fy, fyi. Yep. They want me to find fx and fy. Clearly, I can't use Pythagoras right now. Well, we're going to have to use SOHCAHTOA trig, so I'm going to start to label. Color, 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 color. That 39.6, opposite, adjacent, or hypotenuse. fx, adjacent. fy, opposite. Erica, which do you want to find first, fx or fy? Doesn't matter. You said fx. That's going to be using those two, a and h. Of course that is. What always goes next to the trig function? Which is going to be 18 degrees, and that equals fx over 39.6. How would I get the fx by itself? More specific? You know, it'd be really cool. It'd be really cool if fy was sine. And then if fy was going to end up being sine of 18 equals fy over 30. And I would get the Fy by itself by doing the same thing, except putting a sign there, because then rather than doing Pythagoras, I could just backspace and edit. It would be way less typing. Meanwhile, 39.6 times cos 18. You get 37.6618, 37.7? And that would be newtons. Mr. Dueck, how come you're not including a direction with these? The letter X tells you it's horizontal, or the letter Y tells you it's vertical. I think it is going to be sine of 18 equals Fy over 39.6. And so Fy is going to be this same expression, but instead of a cosine, sine it is. And I get 12.2. And that looks about right looking at that picture, because Fy looks really short and Fx looks longer. 12.2 newtons. So let's pause and think of what we've done so far. We started out talking about subtraction. How do I subtract two vectors? I don't. Add the opposite. And if you give me a slanty line, I don't deal with it as a slanty line. I break it into components. This can turn the page or next page over. Is it turn the page? Next page over?
Next page over.
I would consider this probably an A- or A-level question, this next one here. Adding vectors that aren't at right angles to each other. Sorry, this would be a high B+ because it's not a word problem. I gave you the numbers. If I turned it into a word problem, that would make it an A-. If it was a subtraction question built into a word problem, that would make it an A+. Okay? I've turned the page. It wants me to add 14 newtons due west and 24 newtons at 30 degrees south of west. As soon as I see degrees in a question, I gotta be honest. I go, ugh. Kathy, this is gonna take some effort. Okay. And what's the first vector that they gave me? Magnitude and direction. I can draw that. Yoink. And they want me to add them, so I'll put a plus sign. I'm going to be asking you, Ange, to repeat some stuff, not to make fun of you, but to show you how my brain dissects this. What's the second vector? Magnitude and full direction. I think you missed the degree. 24 newtons. South of what? South of what? West. South of what? South of what? South of what? Draw a dotted line west first. What of west? Go back to where you started. Go south of west. This is where that angle of 30 degrees is going to go. And the line is 24 long, so I'll eyeball it. I'll make it a little longer than my 14. Put your pencils down, look up. One way to do this would be to add these two vectors together. Jagger, how do I add two vectors together? Draw them. And so it would look like this. There's the 14. Tip to tail. There's the 24. The resultant kira goes from the tail of the first to the tip of the second. Is that a right-angled triangle? You're bringing out the sine law and the cosine law, which some of you told me you saw last year. You would say this angle right here is 30 degrees, which makes this angle inside the triangle 150, because that's a right angle. And if you prefer to do it that way, I prefer to do it that way. I'll show you that after school or during the flex. It's tougher, but faster. But I started out this lesson by saying, why would I learn a whole new method if I can turn an old method into a new method into an old method? Do you see an angle? Components. I'm going to break this up into fx and fy. I don't care about the 14, it's already good. Color. Fx opposite, adjacent, or hypotenuse. Fy. Let's find fx, which trig function? Oh, I forgot to label it 24. Hypotenuse. Now let's do that. Which trig function? Cosine. Cos of 30 equals opposite over 24, or sorry, adjacent over 24. I think it's going to be 24 times the cos of 30, yes? Now, this is not my final answer, so I'm not going to round this to 3 sig figs. I'm going to keep like 5 or 6 sig figs because I'm going to be using this to find more stuff. So I'm going to go 20.7846 because there's a 0 after the 6th. That's a good place to round off. 20.7846. Put a little box around that and come back to it. Now I want to find FYI. Which trig function? Are you saying it's going to be sine 30 equals Fy over 24? You get 12, yes? Double check me, but I know sine 30 is 0.5, so when you're, anyways. Okay. So now I'm going to redraw this. You ready? I still have the original 14. Plus, I also have a 20.7846 plus a 12. How do I add 3 vectors together? 2 at a time. Oh, but I said group them cleverly. And I would not, oh, first of all, I forgot to put the 14 on there. Let's do that. I would not add the 14 to the 12 first. Which 2 would I clearly want to add together first? The horizontals. Okay. In fact, you might be able to do that on your calculator or even in your head. I think it's going to be 34.747846, but double check me. Yeah? So now I get new vectors. One big vector going like this, and it's 34.7846. And if you couldn't do it in your head, you would use your calculator, Ben. And I got a 12. Now I have 2 vectors. How will I add 2 vectors together? Draw them. And so what I've done is I've taken a question that I didn't know how to do, and using components, it turned it into one I already know how to do. It's a little bit of work, but I didn't teach you anything new. Now, if you want to learn a shorter way using the sine law and the cosine law, hit me up during a flex. Be happy to show you that. Meanwhile, let's draw my triangle. Here, a resultant goes from the tail of the first to the tip of the second. There's the resultant. I'll call it F and then R for resultant. Color. I'm going to use Pythagoras. Now, I'm lucky. I have this whole number not rounded off on my screen, so I'm going to use this. If you're just using the 34.7846 and not the 0969 and all the extra digits, we'll be off on the 4th or 5th sig fig between you and I. Squared plus 12 squared, square root, answer button. I get a magnitude of 36.8. Final answer. Now I'll go to 3 sig figs. Direction. I haven't got theta yet. Equals opposite over adjacent. Opposite over adjacent. Oh, I typed that wrong. Not 6446. Did I write that right? I think I did. Hope I did. I get 19 degrees. North of south, east of west, what of what? Did you make it? Because that was a long blink. South of west? So how do I handle non-right angled triangles? I turn them into right angled triangles. I use components. One more. I think this is the last one. Oh, no, I fibbed. 2 more. Is that okay? Yeah. F resultant force. And I should have put a vector symbol on there. I just wanted to call it something, and I figure F because it's a force, but I got F's kicking around everywhere in the question. Oh, resultant force. That's the one that I've just got from adding the vectors. That'll work. And then this is supposed to be an at symbol that somehow didn't work very well. Good stretch? Good. Here's an A+ question. It's a word problem. It's an airplane question. I've just turned the page and I see directions, so I'm going to go put a compass rose somewhere on my page. What was the airplane question, the airplane equation? I did put it on your formula sheet. I think it was engine velocity plus wind velocity gives you ground velocity. I think this is engine velocity. I think this is wind velocity. You know what makes this a yucky question, Mason? As soon as I see a degrees, means it's a non-right angle triangle. Oh. Here we go. Engine velocity, 240 east. Well, that's going to look like this. Plus wind velocity, 125 meters per second at 40 degrees north of what? North of what?
West.
North of what?
West.
You're going to go west first. What of west? You're going to go up. Where the angle is 40 degrees and the magnitude is 125. 125 meters per second going up at an angle. Did I say angle? That's a job for components. I'm going to break this up into horizontal. This time, Kira, I'll use a V for velocity because it's speeds. And vertical. That 240 is going to drop down. I'll get the components over here in the margin. I hope. Let's see. Color. 125 is the hypotenuse. I got that. I see people squinting in the back, so I'll zoom in, and then I'll zoom out. So 125. VY, opposite or adjacent? VX. What do you want to find first, Vx or Vy? I don't care.
Yeah.
Which trig function? Yeah, A and H. Good, Captain Obvious. Which trig function? Cos. So it's going to be cos, what always goes next to the trig function, the angle, equals adjacent over hypotenuse. I've seen this dance before. It's going to be 125 cos 40. I get that. Is this my final answer? No. Then I'm going to carry some extra sig figs. And usually if I go to 5 or 6, that'll guarantee that I'll be good to 3 with my final answer. So I'm going to go, I don't know, 95.7556. Now, which trig function is Vy going to be? Is it going to be exactly the same as this, but with a sign there, and I would just am I going to just be able to backspace and edit them? Well, that's convenient. You're lucky you had a teacher last year who ranted about getting arrow keys and being able to backspace and edit. He must really have known what he was talking about. I'll go 80.3485. And now I got to zoom back out so I can get this all on the same screen. I'm going to redraw a little picture. So I still have this. 240. Plus, but now I have a Vx pointing to the left of 95.7556. And I have a Vy pointing up of 80.3485. How do I add 3 vectors together? I don't. I do them 2 at a time, but I try and do them 2 at a time cleverly. I think I want to add the horizontal ones first, except here, I'm going to go bigger minus smaller. I'll add them vectorially because they're pointing in opposite directions. So it's going to be 240 minus 95.7556. The 240 is the winning direction. The winning direction is still pointing to the east. I get 144.2444. And to that, I'm going to add 80.3485. Whew! Oh! How would I add those 2 together? Now, here's the nice thing. This is a lot of work. I don't know if any of it, to be honest, is all that difficult. It's mostly Math 11 and Math 10 trig. But you have to go very systematically. And you'll notice, Paige, I'm not taking many shortcuts now. I'm taking a little bit in the trig by backspacing, but this is not where you're hearing me say, let's try seeing to do if we can do this in our heads with only our calculators. How will I add these 2 together, Paige? Good call. So I'll get a vector triangle that looks like this. 144.2444. Hopefully, though, also now you're understanding why I said over the next few days, you're going to get really good at trig. And this is going to be, I think from the equation, we called it V ground. So now I'll label it finally with what that is. And I'm going to find the magnitude and the direction. This would make a good written question on a test, although this might be a little tougher. This will make a good nasty multiple choice question, although I told you I'd surprise you. Maybe a subtraction with a non-90 degree angle in it? Ooh. Here, I'll bet you I can do the rest without showing any work going all on my calculator, because I've done a bunch of these. Color, 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 opposite, adjacent. I think I can say the magnitude of the ground velocity. I can do the Pythagoras. Ooh, I have the 144.244 stored on my calculator. So squared plus 80.3485 squared, square root. I get 165. Now I'll go to 3 sig figs. At, it's going to be tangent again. Shift tan of 80.3485 divided by 144.2444. 29 degrees north of east. I'm going to do this example next class. I'm just going to write a little pause here because I want to give you some time to start the homework. And I've talked a lot. I want to give you at least 10 minutes. So what is your homework? All of these, I strongly recommend you want to do these on a separate piece of paper to draw your triangles. Although it's conceivable to fit them all. No, I yelled at you about drawing small triangles. This you want to do on a separate piece of paper. I've put the answers at the bottom of each question. Some of these start out fairly easy. 3 kilometers south plus 4 kilometers south. 7 kilometers south. But then we start to get into the vector math. And there are a few that don't have right angles. When I look at number 4, ugh. Ugh. So try just these 4 questions, okay? You have the remainder of class, my angels.